Broadcasting from Boston, Massachusetts, the Smart Cities podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.
Welcome to Smart City Viewpoints. Today's episode is a rebroadcast of a panel discussion on the subject of the evolving energy policies of the United States, as well as the technologies that are driving those policies. Without further ado, here's the panel discussion.
Welcome, everyone, to ARC's continuing Digital Transformation Council series focusing on smart cities. Today, we're very happy to have a panel discussion of ARC analysts on the subject of President-elect Joe Biden's energy policies. First, I'd just like to do just a brief introduction of ARC for those of you who might not know us. For over 30 years, ARC Advisory Group has been the leader in thought leadership for operational technologies and process control and discrete manufacturing, as well as for building automation and the wide breadth of smart city applications for a complete offering of digital transformation products and services that allow organizations to realize dramatic productivity, market share, and profit gains. With that, I'll introduce Rick Rys, who is our senior energy analyst. Hello there, Rick. We have with us Eddie Fidler, who is our transportation analyst. And we also have with us Larry OBrien, who's ARC's Vice President of Cybersecurity and Smart City Software Platforms. So let's just plunge right in. And Rick, just given the change of administration in Washington, can you outline a number of bullet points or things that you'll see changing because of the new administration, as well as perhaps an overview of how this impacts this decarbonization of the utility industry and the energy industry?
Yeah, great. Thanks for the introduction and the opportunity to talk on one of my favorite topics. First, I want to make a comment that in spite of previous administration's effort to support the fossil industry, there has been a considerable downward trend in coal power plants and fossil industries, plenty of consolidations, in the hydrofracking area, even refineries and major oil companies. If you look at their balance sheets, they are under a lot of stress. And that's with an industry that was supporting the fossil industries, an administration that was supporting them. So I would like to make 5 points. The first point I would make is that if we really want to work on this global warming CO2 problem, clean electricity is absolutely required in order to electrify transportation, buildings, and commercial activities. But on the other hand, cars last 12 years and buildings last a lot longer. So this transition will take quite some time. In terms of those entities that will regulate the electric industry, we certainly see, at least in the U.S., NERC and FERC, and we also see a tremendous influence on state Department of Public Utilities, DPUs, that tend to regulate our electric grid with renewable portfolio standard. And there's a lot of recent activities here. FERC came out with 841 order that allowed grid batteries to compete, and they recently came out just in September with the FERC 2222 order, which allows aggregators to compete in the energy markets. And this basically is going to lead to the grid interactive home and certainly have an impact on how electric vehicles are charged and the ability of small players that have the possibility of storage or deferring loads to participate in the grid markets that we have. We have grid markets in the US and Europe. China doesn't actually have grid markets. They kind of have essentially controlled state grid system. Mm-hmm. Second point I would make is, we will probably rejoin the Paris Accord, but it basically sets goals and not really plans. There's no penalty if you don't meet your goal outside of the embarrassment of it. And we do have a lot of goals set for 2030 and 2050, and there are nice starting points. It's very important, I think, to have an impact. It will have an impact by rejoining the Paris Accord, but basically, we've already dealt with a lot of pollution issues in terms of fluorocarbons, acid rains, SOx and NOx things. But at the moment, CO2 is just an unregulated issue, and there's no penalty for dumping CO2 into the atmosphere, and a lot of countries have done that for a long time. Mm-hmm. So the third item I would mention is that Biden basically has suggested that he would like to cut oil and gas subsidies, and these subsidies are worth $15 to $20 billion per year. There are subsidies associated with producing wells. There are subsidies associated with declining wells, and there will probably be considerable opposition from the Republican Party and even from Democratic states that have those industries in their states. So this will be an uphill battle for Biden to make progress on cutting oil and gas subsidies. Generally, it has the fourth item I would mention is that there's kind of a general consensus amongst economists and even oil companies themselves that the fairest and most effective way to really get going on and encourage the capitalistic competition of alternatives is basically to put a price on carbon. The CLC, the Citizen Leadership Council, Climate Leadership Council, which has got huge numbers of oil companies attending, suggested that $40 a ton is a suggested starting price. Also, you have the Citizen Climate Lobby pushing for a kind of a carbon tax. And generally, if you look at climate models like the En-ROADS simulator, that it basically suggests that of all the options you have to reduce global temperature rise, a carbon tax probably is one of the most effective ways of doing that. However, in the past, a carbon tax or even a carbon dividend, whichever you describe it, has been political suicide. However, there is still a tremendous amount of support suggesting that this is kind of the way forward. Cap and trade has been in place in some places, but has not really been as effective as it could be. And finally, the fifth item I want to talk about is that there's been a lot of technology advances, and there are more technology advances needed. In part because of subsidies, solar and wind have been coming in large production, and as a consequence of production and development, the cost of wind and solar is now the lowest cost source of electricity on the grid. Coal plants are basically considered stranded assets, and even natural gas plants, a new natural gas plant will become a stranded asset, before its end of life from a maintenance point of view. So the technical problem that we have is that this non-dispatchable renewable certainly is going to play a big role, but the huge unsolved technical issues, for example, it has been suggested, for example, that DOE funding of $2.5 billion is like 10 times too low. We just need much more basic research to improve the cost of grid batteries, improve the cost of solar cells, develop a hydrogen economy, electrolyzers, fuel cells, the storage, carbon capture and storage. All of these functions are really, really important advances in technology that are just absolutely needed in our future. So anyway, there are 5 things that would give you plenty of reasons for discussion. I'm hoping that we can get some questions.
Okay, well, Rick, that was a lot and very insightful. Can you just quickly go over those? CO2?
Well, I mean, obviously we see CO2 is continuing to rise. It's in nearly 420 parts per million. That CO2, there's a lot of technical arguments, in the Paris Accord about, well, who put the CO2 up there? They're the ones responsible for it. There probably is also the concern that a lot of the countries that never developed coal-fired power generation feel that they have some right to generate with new coal plants and put their fair share of CO2 up there because burning coal is a relatively cheap way to make electricity, right, assuming you don't capture the carbon out of it. But so CO2 is clearly, the big issue here, and if you look at the whole participation, the transportation industry is a huge part of the fossil industry. Electric generation still remains. Natural gas is roughly, is more than 50% of our electricity today. Coal is in decline, but the amount of wind and solar that we currently have, you tend to think we see a lot of solar panels and wind turbines, but we need something. If we really wanted to solve this problem, you need some 20 times more solar and wind than we have today, and that's a huge expansion. And the other thing is we need it sooner rather than later, because of the integrating nature of climate temperature on CO2 concentrations, you need to make changes sooner in our time frame of 2030 to 2050, and current plans aren't quite getting there overall.
Indeed. Before we move on to, I'm intrigued by the impact of vehicle and transportation electrification. But before we move on to there, just for our audience, your 5 bullets. Can you briefly just restate your 5 bullets?
Okay, so first of all, I'm saying that clean electricity is required absolutely before you can electrify transportation and buildings. So, and there's a lot of political organizations that influence clean electricity. So clean electricity is number 1. So Paris Accord is number 2. Subsidies for oil and gas was number 3. Carbon tax is almost in the same category, is number 4. And then all the technology advances that are needed to make renewable power and still handle peaking units and the storage problem, there's still tremendous technology needed. So 5 items. Great.
Well, as we're a technology research firm, I'd like to explore all of those variety of technologies that you discussed. But you mentioned a range. I know that we can go into superconductors and things like that. But let's get started with vehicle electrification, vehicle to grid impacts. How's that going to evolve? What's the future look like? What are the impediments today? And I know, Edward, you've done quite a bit of work there, so feel free to chime in as well.
Edward, do you want to take this, or do you want me to give a brief comment first? So
I think that's for you, Rick, and then I'll.
Okay, yeah. So one of the things that I do believe you'll see happening is the vehicle to grid technology. Of all the lithium batteries made to date, about 90 to 95% of that lithium batteries are going into electric vehicles. As electric vehicles start to become more populous on the grid, you already see a huge concern by electric utilities that peak load on the electric grid is typically between 5 to 9 p.m. And while the electric utilities could just say, well, we'll build more natural gas peaking units and we'll build thicker, bigger, heavier transmission lines, and we'll just let consumers use power whenever they want. However, if you go that route, it gets kind of pricey, and also then, well, if you want to get rid of carbon, that means that these natural gas plants have to have carbon capture and storage. So the other option, of course, is to say, well, you don't have to charge your electric car at 5 o'clock when you come home from work. And that's kind of what we call the shark curve. Everybody comes home from work at 5 p.m., plugs in their electric car, and we already have peak load on a hot summer day. You do that all on a hot summer day, and peak load is going through the roof. Transmission and capacity cost of electricity delivered to the customer tend to equal the cost of the electricity from the source. And that basically means you need to build a lot of power plants that have the capacity to provide that peak power, but they only run 5% of the year, and they just need to be ready to go. And by the way, you need to build these huge, thick transmission lines because we have to be able to handle peak load without the lines overheating. And so what you're going to really see then is that there will be, in fact, this FERC Order 2222 specifically addressed that aggregators must be allowed access to compete in these ancillary service markets associated with peak load, frequency response, et cetera, and put together small players that every single EV owner collectively either could call V1G, which is to defer their charging till 2 in the morning or midnight, which is generally quite easy for most people to do. I know that personally as an electric vehicle owner. And then there's vehicle to grid. With all the amount of lithium sitting out in those batteries, we tend to think of cars as mobility, but really a car is a walking power plant. You could make power out of that car. All you need to do is get that 350 volt DC, convert it to AC, put it into the grid. You could. I would love to actually put a whole load center in the back of my Tesla, all right, and be able to go any place and back up anybody's power in a failure. And I could run my house for 4 days on my Tesla battery.
So, but Rick, I appreciate that forward look into vehicle to grid, and it sounds like it's balanced on a fulcrum of real-time pricing. Can you give us a perspective on the status of real-time pricing today for a residential consumer? It's perhaps a bit frustrating that many of us, I happen to be in Florida, where virtually every meter in Florida is a smart meter, and my intuition would say maybe I should have had access to real-time pricing, but we don't. Can you perhaps talk about the impediments to that?
So first of all, not everyone probably understands exactly how grids are controlled. In the very fast time frame, there's what's called frequency control. If the frequency of the grid falls from 60 cycles lower, your clocks will actually slow down, at least the old style clocks. But that is a signal sent to every generator on the grid, every gas turbine, every steam turbine. Suddenly the governors are set with a droop mode to push more power back on the grid and get back up to 60 cycles. And the East, West, and Texas grids all have their own separate frequencies. And so that's kind of the basic fundamental thing that worked fairly well with vertically integrated power plants. But actually, in order to balance supply and demand, there is a market mechanism called LMP price, local marginal price, that in New England, we vary that price every 10 minutes. And that price of power goes up every day at 5 o'clock. You see that price goes much higher. And every day at 3 in the morning, that price is low. And that's because the demand for power is there. However, I could help to solve that peak problem with my electric car or deferring my hot water heater or other activities that I could do, but I have no financial incentive to do that. I'm not allowed as an individual homeowner to compete in those markets. Large industries are allowed, and large aggregators will become allowed, and those aggregators will be able to collect a large number of individual small players, and these will be, even if you don't have solar or a battery, you have a hot water heater, maybe electric, or you have an HVAC system that could be deferred, and by suddenly being rewarded for that, you might be, we could reduce the cost of electricity someplace between 30 and 50%, compared to the energy. Those are the transmission and capacity charges that most people don't realize are a very big part of your electric utility bill. And yes, smart meters will play a role. But in addition to smart meters, there's also smart load panels. My electric utility has given me a V1G charger. It has a Wi-Fi connection on my electric vehicle charger. And they send me a text message. Last night, actually, I got a text message at 5 o'clock saying, we're turning down your power to help compensate for a high load situation. And they gave me the charger for free, a $600 item, in order to save costs on it. So that's kind of a precursor to how utilities are trying to deal with this peak load problem that electric vehicles will present. But it's not really the best solution. If we were just allowed to compete on the market and decide when we're going to push power out, or allow vehicle to grid or defer loads, and have a financial compensation, most likely with a smart meter and the advanced metering infrastructure that it would take to do that. So we certainly see that coming as the cheapest way for electricity to develop. It's obviously a new paradigm for the homeowner to actually be concerned about the time of day cost of electricity.
So in that example you gave, Rick, in your own home, the demand is being controlled, but you're not in control of it. It's the utility that's optimizing and doing it. And they've incentivized you by just giving you the item for free up front. But from then on out, they're in control.
Yeah, that's true.
Okay. And you mentioned the barrier to a world where every individual resident, driver, and business could take ownership of that is just regulation. It's not so much technology.
Well, there's certainly technical issues involved, all right, because as soon as you start giving a price on allowing me to compete in those markets, I'm going to really be requesting my EV supplier to enable vehicle-to-grid or bidirectional electricity flow, which is not actually enabled in electric vehicles today.
Mm-hmm.
So there's plenty of technology issues in order to manage specific electric vehicles and charge. There's a certain charging regime that optimizes electric batteries. They can put huge amounts of power out. I mean, the battery from an electric vehicle, in my case, I can put 400 horsepower worth of power out. I could fully overload my 200 amp breaker. All right. But maybe that's not how it will work out. And it could be that the electric vehicle manufacturers become aggregators as well. Tesla has promised to allow bidirectional flow going forward, but they have not really. The demand for vehicle to grid is not there, in part because the individual homeowner has no incentive to do it. All right. Suddenly, if you have aggregators saying we can do it, I think that the EV producers will suddenly start to enable that and look at their vehicles not only as mobility, but as portable storage.
So how does that incentive come into existence? Who would have to regulate that into existence?
So there are a number of aggregators. In fact, I just looked at one of them. What was the name of the company that just got formed that actually is approved by ISOs to do this? So what has to happen is this FERC 2222 order has been issued. They have until July to respond to that order. That means the ISOs and RTOs. There's, I think, 8 ISOs and 9 RTOs across the U.S. And then they're trying to develop the new markets and the rules of regulations for aggregators and avoid things like double counting issues that might occur from net metering issues, for example. And then all of a sudden you have these new regulations. And about 2 years from now, the ISOs will come out with a regulator. That's about how long it took them to allow grid scale batteries to push power into the grid, between FERC 741 order and the actual implementation of that. So all of a sudden, these aggregators will start popping up, and they will contact me, and they will say, well, we need to put a smart meter in, and we need to, or a smart load panel, and we need to be able to remotely access that. And based on your performance, we will give you points and or something every month, and we will send you a check every month based on how much power you put in at which times of the day, to handle peak load problems or whichever markets. There's a number of ancillary service markets that the electric grids have created, in part to balance supply and demand. Some on the short term, some on longer terms. There's a day ahead price. There's a peak load price. There's a number of different ways for you to make money that way. And all of a sudden, the aggregator is dealing with the ISO and guarantees that they can have this performance and bids into that market on behalf of a large number of small players. So suddenly if I could cut my bill by 20, 30, 40%, maybe, if I was a really powerful guy that had vehicle to grid and or a solar battery and a hot water heater that could be put on a timer or with a relay, but a lot of things need to happen. You need to suddenly have Wi-Fi on your HVAC system, Wi-Fi on your hot water heater, Wi-Fi on your EV charger, and the software and implementation to do this on a smartphone. And there are actually companies that make video games, out of this thing, and you can gather points and compete with other people about how to conserve and make it more interesting and fun for people to actually follow the electric grid and play the game of doing that. I play games like that already. The sun just came out right now. I could go and charge my Tesla right now, because right now any power I put back to the grid I get nothing for. I have no net metering in my town. So there's a lot of different games that can be played, but you see a lot of technology will come into the grid interactive home.
So Rick, do you see the future as being one of these aggregators that manage all of that, or is it just a smart meter where I put a limit in and I say, if power is this much, if the cost of power rises above this point, I'm going to limit I'll limit my water heater.
No, it's not simply just a smart meter. I mean, in principle, you could have a meter that updates the price every 10 minutes, and you could display that on your phone, and that's basically just the wholesale energy market. But the wholesale energy market is only one market. All right, if the electric grid operators, they need to know they can rely on somebody to push power into the grid when they get into trouble on managing load, and you need to commit to that. In fact, you look at we have a power plant here out in Ludlow, a Stony Brook power plant for 500 megawatts, and they sit idle all the time. They're paid to be able to come up to power, and they can go from a cold start to full power in 10 minutes. And when ISO New England calls them on the phone and say, you must generate power, they must. If they do not generate power, they are fined, all right? Because they need to be that way. So these other markets are collectively, are what the electric grids need in order to manage supply and demand and keep the electric grid operating in a stable manner.
So then I'm just
It's striking to me, Rick, it's striking to me though, and somewhat even alarming to know that someone is on both ends of a telephone line saying, I need more power. When I'm envisioning a scenario where, my EV charger, if I have an EV charger and I'm attempting to sell power back to someone, am I going to need to pick up the phone?
No.
But so how come someone's picking up the phone today?
Well,
in a large entity, for that matter.
Yeah. Well, if you have to understand the complexity of operating a grid, with so many grid operators around the world that are responsible for zone and power passing through one grid to the next, large changes in one section of the grid sometimes run through adjacent grids and can cause problems. In principle, a lot of this could be automated. And in principle, some of the blackouts that we have seen, the 1965 blackout, the 2003 blackouts, occurred because operators didn't take actions quickly enough to transfer power from one substation to a different path and avoid power. So they didn't have the information they need. But there's a lot of concern that and in principle, you could argue that it should be automated. They should basically automatically start this power plant, and it starts up in 10 minutes. But, obviously starting a power plant is a very manual operation in the first place. There's a lot of people running around up on the decks, switching valves, clicking things around. It's not a completely automated plant in the first place. But largely, the grid control occurs on the largest users by phone. All right, it is not completely automated. Now, there's plenty of other automation to assess the state of the system. There's 55,000 substations. All of those substations have information. There's also GIS systems that have maps of all of the distribution networks, and in some cases, every smart grid on that map is part of that GIS display. And you can basically go to equivalent of Google Earth and see who has power and who doesn't during a storm or a power failure situation. And of course, outage management is another huge part of grid operating, and that's very telephone and human to human important. So to coordinate between one area and the other, and also there's competition of who to run when and how some of those decisions should get made. In some cases, like Stony Brook would bid into the market and say, we got a very low price, but they didn't select us to run. How come? Well, that's maybe because you would get paid for a minimum of 8 hours, and they only thought you're going to need for 1 hour. There's all these other little constraints on who generates, what the cost of generation is. But the general idea is that it's an open, competitive, kind of capitalistic market of who wins. And in solar and wind, they bid in at a low price. And if, for example, there's too much power, there's tons of solar, tons of wind, and no load, then the price of electricity can technically go negative. Basically, you would be paid to consume electricity in that situation. And that actually has happened. And you would be penalized if, for example, you're a nuclear power plant and cannot shut down. You're penalized for pushing electricity into the grid because you couldn't curtail. Wind and solar under those circumstances would get curtailed. It's rare, that situation, but that situation will increasingly happen with more wind and solar, which always bids in at $0 a megawatt hour.
Right. Edward, do you have any questions?
Yeah. So just just looking at that vision of E2G and the demand side, personally, I wouldn't really be interested in doing the gamified, version where I'm controlling my charging and everything else. I would love to just sign up for an aggregator service and have them all optimize it algorithmically. So, we want people to understand that you're not going to have to sit there on your phone, micromanaging each of your appliances all day if you don't want to. Maybe enjoy that.
Exactly. So clearly that the automation function is critically important, all right, for most people. Most people have just taken electricity for granted. It's always there when they want it all the time. And they're not used to this mode of operation at the customer level. Large industrial users are, because, they can, in fact, compete with the grid. And then in some cases, they're asked to curtail if they can. And so the gamification is kind of one strategy for aggregators to get people more involved. There obviously will come situations where they automatically turn down your air conditioning at 5 o'clock and you didn't like that. You're going to want to override that and say, no, I really having a guest activity here today. I want to keep my house cold today. Oh, I really wanted to charge my car now because I need it later this evening. You're going to want to override those automated functions. But clearly, the ability to automate those, and that's why I mentioned that, you really need to have essentially a Wi-Fi electric hot water heater, a Wi-Fi electric charger, and Wi-Fi connectability to your heating or any other significant load that might be useful for making you money. And of course, now you get the financial incentive to do that. If you save 20-30% on your electric bill, and all you need to do is put a smart meter in and load some software on your smartphone, wow, that might be worthwhile.
Yeah. Rick, you don't happen to know if that Wi-Fi connection requires interoperability. So do you happen to know if there's been efforts to make interoperable APIs for your water heater, dishwasher, EV charger, oven, air conditioning?
Well, certainly like Mitsubishi mini split heat pump, that's two-way. You can remotely see the temperature in the room. You can remotely turn the temperature thermostat on, off. You can move it from heating to cooling. That API is already built into many functions. It's not typically built into a hot water heater, which is one of the other killer apps. And it's not currently built into most EV chargers that are sold at home, but it is built into the ChargePoint charger that I have at home. So it has Wi-Fi, it's interoperability. It's actually this MWIC, Mass Municipal Electric Company, sends a signal, cuts off my power. Actually, they don't cut it off. They move it from a level 2 to level 1. So they don't cut me off completely.
Okay. I do see that everything from, even I've seen where even gas ranges have Wi-Fi connections, vent hoods, cooktops. So it's certainly coming. My question was frankly more about these aggregators. Are they going to need to support hundreds or thousands of different drivers for each device?
Yes. Yes, they will.
I think they will, right?
So they're going to need to develop APIs. They're going to need to understand the charging characteristics of every different electric vehicle, and they've already done that. There's this one company, I think it's called Nuve, N-U-V-V-E, that's just got formed as it's not even quite on the stock market yet. I think I sent Edward a link to that. They are an aggregator that's already looking to expand tremendously, and this is a multi-billion-dollar market. It's aggregator responsibility is considerable. There's plenty of software development, plenty of APIs, and then plenty of financial management. All right, I mean, you could be dealing with you have to deal with ledgers and maybe blockchain and other technologies, get involved in terms of keeping track of the financial impacts because, people kind of pay attention to their bills. I always like the comment I got from some draftsman down in Texas. He basically said, there's basic physics involved here that voltage moves electricity, pressure moves fluids, and money moves people. And the money moves people part is what's missing right now in our electric grid. I have no motivation to push power out in the grid, even though it would save our town and utility capacity and transmission costs. if I had that, it might be a motivator. I would probably do what I can voluntarily. There are some utilities around here, for example, that will send you a text message. Oh, if you please could reduce your power use right now, it would help us reduce our transmission costs. And just be a nice guy. We're not going to pay you anything, but just be a nice guy and reduce your power use right now on a hot summer day. Turn your air conditioning down for us, please.
Great. Well, Rick and Eddie, thanks for all of that. At this point, I've just unmuted all of our attendees. So feel free, if you're an attendee today, to announce your name, unmute yourself, let us know who you are, and if you have any questions for Rick or Eddie, myself, or Larry for that matter, just feel free to jump in.
Well, people work with their courage.
We did have a comment from the audience, Jim, on fourth generation nuclear reactor technology and its impact on the environment. So I don't know if anybody has any comments on the future.
Yeah, Larry, that's what I was just going to bring up.
Oh, okay.
Go ahead.
Sorry about that. I didn't mean to bump you out there, Eddie.
Okay, yeah. So one of the questions from the audience we had was, at the start you were talking about renewable power, right, solar, wind, but they brought up the point that nuclear, especially fourth generation reactors, are just as good or better.
Well, there are many people that believe that the only solution to really deal with the greenhouse gas is to include nuclear in the mix. And certainly, actually, we've seen nuclear power plants actually in decline. Nuclear power plants are having a hard time competing today in the current marketplace because their fixed operating costs are very high. They are required to do training. They are required to do a number of NRC upgrades as a result of the Fukushima accident to put in different backup systems and the ability to have cooling systems. Perhaps the most popular idea is the small modular reactor that, this company NuScale has recently got a number of preliminary NRC approvals to move forward. There's a number of different small modular reactors. The basic idea is you could build a reactor in a factory, get it certified in the factory, and just move it to site. However, it still has some of the same problems using the same uranium fuel cycle, with radioactive waste and terrorist, issues, and so they would tend to need to have the same level of security that a regular nuclear plant has. But nuclear is certainly the possibility. And then the other thing which I tend to follow as well, because I do have a little background in nuclear, is the molten salt reactor. There was the molten salt technology was actually ran in Oak Ridge, Tennessee, and made power for 4 or 5 years. It's a proven technology. There's much more thorium involved, and the fuel cycle of thorium going to uranium-233 produces a much lower life cycle of radioactive waste, 300 years compared to 10,000 years. And actually, by mixed fuel cycles, you could actually burn up waste fuel from existing fission reactors in that type of situation. But there are quite a few billion dollars worth of development away. They have a lot of material construction with molten salt, but they're inherently safe in the sense that nuclear power plants, you really need to have the capability to be able to have humans completely walk away without melting down. And the current designs of reactors, the RMBK, the pressurized water, boiling water reactors, you cannot have humans walk away. They must have electric power because the residual heat in those fuel must be cooled. And that's why Fukushima melted down 5 hours after the electrical switchgear got covered with water. They just couldn't get cooling to it in any way.
Yeah, it's interesting you bring up thorium. I noticed thorium technology really flies under the radar. So it might be worth just briefly giving the basics of that for our listeners here.
Yeah, I mean, it's a fundamental fuel cycle. There's a couple of interesting comments that were made. One of the comments you may have heard in the early days of Admiral Rickover when he was coming up with the design of submarines and things was nuclear power is going to be too cheap to meter, right? And that comment was based on an evaluation of what the Earth came with. The Earth basically came with 40,000 times more heat of combustion energy with the fissile materials that are on the surface of the crust of the planet. That basically is uranium and thorium are the essential ones, compared to the total amount of hydrocarbons that existed in the planet, all the gas, coal, oil. So there's so much more energy on the Earth's crust in nuclear energy than there is in, and that's not even counting fusion. I mean, this is only fission energy. That was the idea, too cheap to meter.
Mm-hmm.
And in the early days of nuclear power development, where they were looking for a fuel cycle, there was also the considerations to build weapons grade, to build nuclear weapons. And the uranium fuel cycle, with the formation of plutonium and, was well suited to make nuclear weapons. And to a large extent, that influenced the cancellation of the thorium technology and research, which was fairly well developed actually back at Oak Ridge. And so we basically went down the path of a uranium fuel cycle. The thorium fuel cycle was basically just abandoned, even though it was ironically developed in part to see if they could make a nuclear-powered airplane, which was absolutely infeasible at the time. Although it is possible to make small nuclear reactors, very small ones, but nevertheless, we abandoned that technology, and there was a lot of research done. And there are a few companies I know. I connect to one guy, Ron Sorensen, I think his name is, that is at Fiber Energy, FIBRE. That they have got a bunch of money in research, and you see a lot of thorium research going on in India, which has a large thorium reserve. There is a lot of thorium around there. And even China has a large number of people working on a thorium reactor. But it's quite a few years away, just in terms of being able to get approvals.
Rick and Eddie, we have another question. How does the autonomous vehicle industry affect future energy consumption and the environment? There's a lot of models that are divergent on that subject, so I'd be interested to hear what you both have to say.
Yeah, they sure are. I will just say about thorium, Rick, it's fascinating that the thorium path wasn't taken specifically because it was so safe and so difficult to make dangerous, even though that would create virtually infinite, safe, clean energy for us for all of the future. Something that drives engineers like us kind of crazy, right?
On the autonomous vehicle front, one somewhat amusing anecdote to me is that if we have a large amount of autonomous vehicles in an urban area, and parking fees are hit a certain point, you may have incredible traffic jams as autonomous vehicles circle the city block looking for taxi riders. And it may defeat the actual goals, some of the more lofty goals of autonomous vehicles. But what's your perspective, both Rick and Edward?
Let me give one comment first, because I was recently reading the MIT study on the nature of autonomous vehicles. And, one of the projections they would have is you suddenly had autonomy that could deliver you door to door, right? You could just call up an Uber, the car shows up, and because you don't have a taxi driver, the cost is 1/4 of what it is today, because 3/4 of the cost of an Uber is the driver. Mm-hmm. If all of a sudden you had that situation, and particularly under the situation of COVID, you're going to have people that are going to prefer to take a self-driving car rather than take public transportation. And as a result of that, in the city environment, the road traffic will be actually increased as a result of autonomy, and maybe it still is much more efficient, but that's kind of one interesting characteristic. But I know Eddie probably has a lot to say on this topic.
Yeah, Rick, I had the chance to attend that event at MIT where, the head of the MIT Energy Initiative and the head of the university presented the results and everything. So what they found was a little troubling, where if autonomy is completely pervasive, it's possible and very cheap, it siphons riders away from public transit, thereby negating a lot of the congestion and environmental benefits as well. The other thing, a lot of this is just projecting out, of course, but the other point could be that if your commute to work is a lot less strenuous because you're in the back of the car reading a book or with your feet up, maybe you don't mind a 2-hour commute from the suburbs. So maybe you're no longer incentivized to live near transit or near the city or in in an exurb, but you can live 2 hours out, thereby increasing the number of cars on the road and vehicle miles traveled. So that could lead to absolute gridlock. But a lot of this comes to incentives, as you were saying, Jim. So if again, parking is expensive and driving these vehicles is really cheap, they might just drive in circles. So that's where policy comes into it, and incentive building, road user charging, electronic tolling, curb management.
So Jim asked about autonomous vehicles, and that's not necessarily restricted to cars, all right? Because there's a number of companies that are very interested to develop air taxis. Uber has a whole air taxi division. They are very much envision a whole terminal similar like you'd find in an aircraft terminal. You walk in, you get a refreshment, you get your coffee, you hop into an autonomous airplane, basically electric powered machine that has no pilot, is completely autonomous. There are a few people monitoring all of these machines, maybe 4 to 6 passengers, and it can drive you, 40, 50, 60 miles across the town, particularly useful for LAX or Los Angeles or some larger cities. And basically you could get air taxi service, and the level of autonomy required for air taxis, where you go from a known landing spot to another known landing spot, is relatively straightforward from the technology compared to the difficulty of autonomy of driving automobiles on the surface of the road through construction zones, and with policemen waving you down or giving you hand signals, or somebody else aggressively attacking you for your lane.
Yeah, well, Rick, that's on one end of the continuum. The other end of the continuum is we already have arguably autonomous scooters that retrieve themselves and drive themselves back to be recharged at some home base. It doesn't seem, even with the tremendous economic advantage of an electric vehicle for food delivery, we would all agree that to deliver a pizza, you probably don't need an electric car. You need a smaller device, which is not much different than your electric scooter. I can imagine a scenario where those little deliveries are a majority of the vehicles.
Yeah, I mean, what you're talking about is drone delivery, and again, this is a huge multi-billion-dollar activity. You see, Amazon has patents on the Beehive drones and packaged last mile distribution. They puts the heaviest items, still go by rail or truck. And then once it gets to a kind of a warehouse to unpack these things, small packages are buzzed out with drone after drone. I'm just waiting to put that little landing pad here out in my yard here. All right. And that's the landing pad for package delivery. And I have another spot for the landing pad for Uber for his air taxi as well. And it has to be a little further from the house, but in principle, I mean, these are a little bit out there, but they're what's
and
coming.
Hopefully, nobody hacks into that device and does something nefarious with it, right, Rick? I just want to mention the importance of a cybersecurity framework for all this stuff too, since that's an area that I cover. And there is no cybersecurity framework right now for autonomous vehicles, and particularly with 5G, which is going to be controlling a lot of these vehicles. So we still have some work to do before this technology becomes secure, and certainly before it becomes secure in any standard, industry-wide way.
Yeah, absolutely. A huge correct point. I mean, many of us may not remember the Jeep hack where this I don't know what you call it, hacker, that was demonstrating the vulnerability of the Jeep vehicle, hacked into the vehicle, turned on the windshield wipers, turned the air conditioning on full, eventually pulled the car right to a stop, while it's driving behind somebody that was driving this Jeep vehicle. And Jeep had to recall that software and add that security. And so cybersecurity is kind of essential across the board. It's essential in electric grids. It's essential in autonomy. It's essential, even in the modern car today.
Yeah.
I just wanted to put that out there. I wanted to say something too when you were talking about increased Wi-Fi connectivity for home devices like hot water heaters.
Yeah, we often refer to Internet of Things, as this big, huge market of all these devices. But one of the characteristics of Internet of Things is they tend to be to get them at low cost often sacrifices some of the functional requirements for security. So not every Internet of Things device comes with security. Things like Z-Wave, Zigbee, and some of these other communication technologies just don't have some of the security built in.
We only have a few minutes left, so I just like to pose a question. ARC does create a report annually about the top 10 technologies for smart cities. Let me pose a question here. We'll go around from Larry to Eddie to Rick and myself. What would be your standouts about technologies that are on the horizon, that are perhaps being implemented, that are most impactful in the energy industry?
Maybe let me go first then. All right. Because I could at least have 10 myself. All right. Obviously, the whole hydrogen infrastructure still needs a lot of development. It really has a problem that electrolyzers at 60% efficiency and fuel cells at 60% efficiency give a round trip efficiency of 36%. So they need a lot of work on that technology. Batteries, lithium batteries are absolutely going to dominate for electric vehicles in the short term. Maybe solid state or some other technologies will eventually displace them. But we absolutely need a technology for grid scale batteries made out of materials that are abundantly available. Get rid of the cobalt, get rid of the nickel, get rid of those expensive components that are currently in the lithium batteries, and make them batteries. And there are some companies that are coming out. There's one company, OBrien, for example, is a startup that is looking to make it a battery out of common materials. So I would say batteries, but there is still plenty of room in the software area for improving the automation of everything, electric grids, the home.
Sure.
So there's just a few.
Eddie?
Mm-hmm. Yeah, I will throw in, because this is focused on energy, electric vehicles first and foremost. And at the start, Rick, you mentioned that, as we electrify transport and buildings and appliances and industry, it's key to use clean power to do that. I think, which is absolutely true. But there is a bit of a misconception sometimes that using an e-vehicle on today's power grid is the same as driving on coal. There's no point. And it turns out that because EVs convert power to motion so efficiently, even today's power grid here in the US, today's generation distribution between natural gas, coal, renewables, nuclear, you often see a reduction in emissions of at least 50%, often 60, 70%. And so that's on today's existing grid. And what's really cool is that it's getting cleaner every year. So if you buy an EV now, you're polluting 70% less. In 2 years, you're polluting 73% less, right? And every year it's actually dropping. And there's no other vehicle that's actually cleaner every single year. Mm-hmm. So I'll just throw that out.
But I would add a couple of points. One is the embedded energy of electric vehicles to manufacture that battery is still pretty high. And actually, technically, a Toyota Prius has got lower carbon footprint for the first few years of life. And also, even if everybody went with electric vehicles, this is only a very teeny dent in the problem. All right. Energy efficiency is absolutely required. I actually attended a webinar yesterday from Hydrocarbon Processing Magazine that had Aspen Technology speaking about how to convert refineries to become net zero. So imagine an oil refinery that could basically produce all of its products without generating any CO2. That's pretty far stretch, because roughly about 5% of the crude oil that goes into a refinery needs to be consumed to run the refinery. There needs to be tremendous heat for distillation, reactors, and plenty of electricity to move pumps and things around. But so all of these other areas of buildings and transportation, there are so many other places that the energy needs to be improved. Electric vehicles are important. They make a small dent. It's certainly, transportation is a big deal. But
yeah, I'll offer two impactful technologies. And first, Larry, I'll borrow from you and your work on software platforms. Certainly, we need to collect all this data and create business intelligence around it. So smart city platforms are very important. And on the other end of that smart city platform are terminal devices. And as a result, I think what's extremely impactful is the impact of digitizing lighting. Lighting had been an analog device. Now it is a semiconductor driven by LED lighting. And typically, you almost can't buy an LED light today that doesn't have communications in it. So each light source that you see in your home, outside, wherever you go, is potentially a data collector for other devices in the area. And that's going to hasten all of that data reporting back to the head end and that business intelligence that allows us to load shed, to have real-time pricing, and to drive this vision forward.
They are data collectors, Jim. And speaking about smart city platforms, this creates a huge data management problem because you have all these different sources of data coming from different devices, and none of them are in any kind of a standard format. And APIs alone aren't the answer to this question. You need technology that can be able to, that's able to take this data from all these different sources and put it into a common context and a common visualization. And there's a lot of technology.
And arguably, there are some initiatives I know from Project Haystack to others to the U.S. Department of Transportation really has focused a tremendous amount of resources on interoperability. And generally speaking, the 20 or 30 different terminal devices that might be on an intelligent road are plug and playable today, and their data format, their API is unambiguous, and it's published and it's public. It's going to be a while before we do that for the utility industry. Never mind the remainder of all the verticals, in a smart city. We're coming up on the end of the hour, so I want to thank everyone, Rick and Eddie and Larry, for joining us today. We do have a few upcoming episodes of this Digital Transformation Council of Smart Cities meeting. In 2 weeks, on December 16th, Edward will be leading a discussion on President-elect Biden's transportation policies, where we'll focus more on connected vehicles, electric vehicles, vehicle to grid, and some of those issues. Then early in January, we will have a session on the top 10 smart city technologies. That should be fascinating. And then we will round out January with a workshop using the IEEE Smart City Planning and Technology approach, all about stakeholders, user needs, consensus of user needs, and how you plan a smart city project. An interesting point I really like to make to all of you end user attendees today is that attendance, if you're an end user and join us on our DTC meetings, you are eligible for a complimentary ticket to the ARC annual forum. The ARC annual forum is typically held in Orlando. We typically have well over 1,000 senior leaders, 6 tracks of just very compelling, insightful technology and management information. Our Orlando event is one of 4 that we host around the globe. This year, we're breaking it up over 2 weeks. So our first week is industry, process control, and discrete manufacturing. And in our second week, we have a smart city program as well as a logistics program. So if you are an end user and would like a complimentary ticket to our ARC Smart City Forum, feel free to reach out to myself, Rick Rys, Eddie Fidler, Larry OBrien, or any of the rest of us on the Smart City team here at ARC. With that, I'd like to thank everyone for attending today, and especially Rick, Edward, Larry, and all of the fairly large number of attendees we've had today. So thank you very much, everybody.
Thank you, folks.
Everybody.
Thanks. Yep.
Broadcasting from Boston, Massachusetts, the Smart Cities podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.